the same optical density on the film. Theory will work no matter where you take x-rays in the world, okay? So it is important. The fundamentals. Do you understand what you're doing? I don't want you guessing and taking 3 and 4 repeats on my kid, okay? Which is happening out there. That's not good. Relationship, inverse square law. Okay, this is the first thought. I've got one more thought, and then we'll move on into grids. Inverse square law, relationship. Now, how are they going to answer the question? Of these 4 different techniques, which one would give you the highest optical density? That's a relationship type problem. Over here, they want you to maintain the same density. They want you to maintain the same optical density on the film. This is compensation. Okay? All right? And we're going to do that with screens. We're going to do that with grids. Usually we have one type, like in our lab, we have detail screens, we have high speed. We know high speed, we can use less technique because it's faster. Think photography film. You go to NASCAR, you're using 800, 1,000 speed film so that you have a really short exposure to stop motion. If you want good detail resolution, we would use 25 speed film. You're going to blow it up into a poster, okay? That pretty flower or something, whatever you're into. All right, one more thought. Okay, everybody got this? Do you have questions on this? Okay, relationship, compensation. If you got individual problems, see me, let's talk about it one-on-one. The next thought is this. I had went over it last time. When you go into the national boards, or even your test over grids, this is what I would write down. This is what I suggest you write down on a blank piece of paper. You would go non-grid, 1, 5 to 1, 6 to 1, 8 to 1, 12 to 1, 16 to 1. Those are the common. You write this down before you ever go into the test. I gave you the conversion is this. But I'm going to show you one better way, or a different way. Make sure you have this in your notes. That's something. Okay, that's the formula. If you don't like formulas, I don't like formulas. Let me show you a different way. Real world application of going from one grid to another. Here is the application. Supine abdomen, KDB. Okay. Patient comes down to the department, an inpatient comes down. We photo time. I had mentioned this on Monday. You photo time. We set the KDP, 75 KDP. I got a readout of 480 mass. It was nice. I got a Cadillac piece of equipment. It gave me the mass readout. I've got a diagnostic AP abdomen. You with me? Bucky's, 95% of the time, are 12 to 1. This grid factor or Bucky factor is 5. That's how much we have to go up in mass. Grids have lead in them over a tabletop just cassette. Now, would we do an abdomen without a grid? No, because there's too much scatter. It's so grayed out. Again, criteria, 10 centimeters or bigger, thicker, we use a grid. We use them everywhere, so we need to get comfortable. What I want to show you is I use 480 mass in the Bucky. If I take that down to non-grid, I divide by the Bucky factor. 480 divided by 5 gives me what? Who has a calculator?
96.
96, thank you very much. 96 mass is what I would use non-grid. If I have to go do that same patient portable, and I'm going to use a 5 to 1 grid, And there's a reason for this. 5, 6, 8 to 1, you have what's called more positioning latitude. You have more room for error. 96 times 2 equals 192. I would use 192 mass. You keep the kVp the same, because that controls contrast. So what are we doing? We're dividing to go to non-grid and then times your new grid. Is that what we're doing right here? Yeah, it's the same thing. If you don't like the formula. Question?
When you drop the grid ratio, doesn't that decrease contrast? You have to adjust the kVp to compensate for that. You want the same contrast.
We usually don't. For simplicity, I could use 75 kVp on everybody in this room. We know the lower the kVp, the bigger the range of mass. Somebody petite, 20 mass, up to 800 mass I've used. When it was with chess, 110 kVp I could use on everybody in here, but it's only like 2 to 8. It's a very small.
Well, if using the increased grid ratio doesn't make a difference in contrast, why would you use it?
Any variable has an effect on optical density. Mass is directly related to optical density. So we tend to keep the kVp alone because that has an effect on contrast. It's just simpler to just change one variable. Could you do both? Sure you can. This is why you're going to take a lot of notes in clinic. 5 different technologists. One person goes up just mass. One person goes up kVp. Another technologist goes up half and half. And we can show you by fundamental theory, why are they all producing diagnostic films? Okay? Fundamental theory. I didn't have this fundamental theory as a student. I did a lot of trial and error. Okay?
So if you don't have one of the major ones like 5, 6, 8, 12, or 16, you got like a 10 to 1, are you going 4.5?
Okay,
Because it's
now.
in between?
I'm glad you brought up 10 to 1. 10 to 1 is not a common grid. We put 10 to 1 here, factor of 5. Make sure you have that in your notes. 10 to 1 and 12 to 1, we group in at a Bucky factor, grid factor of 5. Okay? Those are the most common. We're going to talk about where would you use 12 to 1, 16 to 1. Most Buckies are 12 to 1. We're going to talk about in the study guides, we use these for portable work because they're much more, they have a higher margin of error. You have more what's called positioning latitude. It's just like these blinds. When they're fully open, like that one over there, I can see out just about any angulation I want. I can see out. As they get more and more closed, they are more critical that I am parallel to the slats or the grid lines.
Yeah, they showed us last class that ratio thing on the height, so width ratio.
Yeah.
And that should make like total sense.
Okay. Okay. And I had put out there the gospel that you can have the same, you can have 2 grids that have the same grid ratio and yet different frequency, and you have to take the frequency into account. The higher the frequency, the more absorption there is. Therefore, you would have to use more technique, therefore more patient dose. So we'll talk about that some more. Okay? So this is the formula to convert from one grid to another. But this is the application. Whatever you started with, take it to a non-grid. Now we wouldn't do that because there would be so much scatter on here. You would have lower contrast because it's more gray times the new. When we do portable work, we need manual techniques. There is no photo timing when you do portable work. And this is why you're picking the brains of the technologists out there. I got a requisition for an angle, portable. What technique should I use? What do you think? Based on experience, you use what they tell you, and you write it down. Please write notes every day in clinic. Be a journalist, okay? Don't try to memorize things.